Okay, so thank you for joining here in day 9 big data series. So you will find all the video here over the 𝐒𝐿𝐵𝐾𝐫𝐻 YouTube channel and myself Dr. Satyana. I'll be from this data source. I'll share this data source. I'll share this file here on this link over the day 9, and you will be clicking over this link.html. When you will click over this KDD Cup 1990 dataset, why I'm more interested over this dataset? Because can you see this dataset is very big. Can you see this is the MB dataset? Sometimes it
Yeah.
is 18 MB dataset. So sometimes it is 45 MB's dataset. So if I click on this task description, it will have this entire scenario. Or if I go for the features, this is giving the entire scenario. What is the feature length, connection, source byte. So in a nutshell, what is the data set? What is the background of data set? This is the transactional data set which is used to deliver packet from source to destination. Whenever any candidate write an email, he sends any email from one location to another location. So he is having such kind of scenario over the router, over the switch, over the gateway, over the internet, over the traffic feature. So if you can see, this is the all about symbolic and destination, source, server name, or maybe this is not very much familiar you might be, but just think about this is very big data set, and we had the buffer overflow, load, multi-hop, Neptune. So may not be, we are not aware about these terms, but this is the TCP packet starting and ending data set. If I go down here, I'll have to import this data set in my local machine. So how would I import this data set? First, I'll use this pip install PySpark. So this is the first step I'll have to import. I'm not going to run this code because this PySpark is already installed in my workspace. So I'm going to comment this section because this is used for collab laboratory. So if anyone has not installed, or maybe you have very first time you are using this code, then you will have to write this code in your collab in your collab notebook, in your big data notebook. Now go
Yeah.
back to the original file. In the previous file, in the previous data set, we will be doing on this previous session. If you look back in the video or in the series, we had this data set, which is the CSY or office data set. Can you see the size of this office data set? If you look at the student data, if you look at the show more properties, can you see the size of this data set? What is the size here?
76.
So
Yeah.
if you look at the student data, you will have so many rows and column, so many records are there, on 1000 records. Of course it's not very small data set, but can you look at the size here, entire size of this file? This is only of this one, 74 KB. When I say 74 KB, this is the single sheet, but when I say 17 MB, can you realize the size of the data set? What is the how many rows and how many columns will be there?
Yeah.
This would be millions, and also sometimes billions as well. This is the reason in such scenario SQL got failed. So why? This is the first reason, first question, why is we are not using SQL for such query? Why we jump to PySpark? The PySpark is capable to handle these big data set where we have millions and billion rows, whereas conventional codes where we are discussing all these leverages part, we had SQL which got failed, which is used only for small data set or not for big data set. When
Yes,
we
Sachin.
talk about the Python itself, it is sometimes got failed to operate or to process or to transform basic or a big kind of very large data set there. So this is the reason I'm going to import this data set in my workspace. What is the workspace? This is the workspace. So how to import this workspace? Let me show this part here. So I'm just creating this part and just importing from google.colab. I'm going to import drive. So what is the drive here? This drive is nothing but Google. Go for the Google and look at the drive option. This one is the drive. So in order to access drive location, drive file, my objective is to get this code using the code only google.colab, like accessing drive from the Google inside the collab. I'm using this code. Am I clear? Or I'm just writing here for mount, just writing this code content and drive, and then going to run this code. So what will happen here? It will allow me to access this drive because this is my private property. This is having so many confidential files. This is having so many like conventional things here. So I cannot give permission to access my Google Drive. Am I clear? So this is giving so many formalities here, requesting access to access my Google Drive files. I need to grant access to my permit code executed and all these um, scenarios. So I'm going to connect my Google Drive here. It's again saying which Google Drive. So I'll say yes. Hey, collab, just access my aim tutorial Google Drive here. Just yes, you can share all the name, email address, and everything which is stored in my Google Drive. Continue. Now continue. This all practice just because of exercise my private property. Whatever is stored in your laptop, I cannot access. All right. So I can access. I You can share every file to me, but you cannot give your entire laptop. In the same scenario, I cannot give my whole drive access to anyone. Can you see here? This is now showing drive option which I imported there. If I go here, this is showing big data, brain tumor, class, collab, codingle assignment. And if you look at the drive folder, inside this directory, all the folders are showing here. Can you see? Big data PySpark project, big data PySpark project. Classroom is there, classroom folder is here. This one is the classroom folder. Codingle folder is there. This is the codingle folder. So any collab notebook data sets is there. So this is also there. If I look at the data set, so can you see this data set folder is there? So all the folders and same directories are available inside the collab. Now I can access all the files from that field. I just try to access all my fields. Why I'm doing this one? Because this file is very heavy, which I'm going to use this knowledge discovery, data mining computation, and this one, this KDD 19, this uh, big data file is very heavy. So I cannot access from my local machine. Yes, of course I can access, but I'm going to use remotely. If you ask me to, hey Sachin, you can access my Google Drive, I can do that. So you are uploading that file in your Google Drive and will give the permission to me. certainly I can access from your Google Drive. So this dependency is not there from the file. Now I'm going to access the file. So I'm going to read and load data to Spark. So using this term, I'm going to use rdd is equal to sc dot text file, and from this text file I'm going to access this one. But if you look at this one, I had already uploaded this big data PySpark file, dot 𝐾𝐽. What is this 𝐺z? Can you see the file size? This is 17.28 MB. This file size is already uploaded here. If I open this folder, can you see this is already there? So this, if it is not there in your drive, so you will have to upload manually. I'll share the file this size. So where will I get this file? So if I go here, I can download this kdd data.gz. So from here, I can upload this folder, this file over my drive folder, big data PySpark project. You can name it any folder here.
Yes, Sachin.
Now once I upload it here, so it's also showing here. I can give copy path from this folder, and now I'm going to provide it here. But before this one, this is the Spark session. So I need to initialize Spark content. So using the Spark content, I'll have to import PySpark, import Spark context, comma, Spark conference. So this is the first. So I'm going to create conf variable. Using this conf variable, I'm going to convoke a Spark configuration. Using the Spark configuration, I'm going to set my app using the app name. Name it, let's say Siva Big Data 70 MB, and this 17 MB is very big size for my file, where we had files in MBs, oh sorry, files in KBs, files in bytes, file in very small sizes. Here we had 17 MB file, which is very big data set here. So I'm going to set this master here. Using the master, I'm going to say local. Using the local, I'm going to just write here. This is the code, and using the sc, I'm going to Spark context. This is the configuration here, and going to print sc first, then print statement go. Just printing this, initializing this statement, and Spark context go, and small mistake will create big problem, and I cannot go with the next command. It's initializing my Spark using the distributed system, using the partitioning, using the RDD. So just see, it's ready to go, and now I can read and load my data from where? From the Google Drive, which I access right now. If you look at this file folder, this is the content, this is the drive. Inside this drive, I had this big data PySpark project folder. This is the big data PySpark directory. Inside this big data, this is the big data file, which is 17 point something. I'm going to initialize this RDD, and now I'm going to use this repartitioner the dataset. I'm going to explore this one, and I'm going to repartition this dataset. All right. So
Yes, Sachin.
So let's create and okay, let's see. Uh, let's see how many partitions do we have in my datasets currently. All right. So currently, I'll check get using the get number of partitions which is available for my dataset. Can you see? It's only one. Why one? Because by default it says that by default the number of partition is determined by number of cores available in my local setup. For example, if my setup is having more clusters, more cores, so it will have more numbers here. But currently my laptop is having only one core, one CPU core. So if you're running it locally, it often based on the number of CPU cores. My local machine central processing unit is having only one core, so it's showing only one core here. All right.
Yes, Ajay.
So if I want to go for the more partitions, so I'm going to create as the create RDD with a specific number of partitions. So I'll use RDD equals to s dot parallelize. So parallelize, I need parallel processing. So I'm going to use parallel processing using this value, right? Or just wait, how many partitions do we have? The gloom.mem.length of collect. So let's see what's the output now.
Yeah.
It's taking much time. Why? Because we had so many rows, so many columns we had. Can you see? These
Yes,
many,
Ajay.
this is the size of the data set. But see, if I go back here, uh, Google, and if I look at the in words, can you see? 4,898,491. Can you see how many rows do we have here?
40. Oh, so big.
4 million, right? So this is really big data set here. So first I'm going to show the gloom transformation. What is the responsibility of gloom transformation? It is going to transform each partition to the RDD into a list. Instead of working with individual element, you now have a list of elements for each partition here. And what is the map length is doing here? This map length is just going for the applies length of the function in each partition, which is now a list to get the count of elements in that partition. So in single we have one partition. In that partition, how many count of elements? This length is just doing this number. And the collect, what is the responsibility of collect? This is the last function collect here. Collect the results back to the driver as a list, giving the count of element is in each partition there. All right. Okay. Let's see. Uh, let's see for custom data set, how custom data set is working over there. So for example, we had any data which is just having this uh, list. Inside this list, I'm having this name Siva, and he's got marks 30. Then the next tuple is, let's say, Sachin. He just got marks 25. The next tuple is, let's say, Manish. From this Manish, he got 41. And next I had this next tuple. The next candidate is, let's say, Lavya. From this one I had 47. Then the next candidate is, let's say, Varun. Using this candidate is having 72 marks. So this is the data set here. All right. So your list of data is just showing here. So I'm creating, just forget about this above data set. This was the extracted from the given folder. Now I'm going to create another data set in order to explain the function individually. So I just created a simple data here, and using the data set, I'm going to convert the list. If you look at the type of this data set, so let's say the type of this data set here. What is the type here? This is the list. This is not RDD. So I need to convert this data set, convert the list to an RDD. So how would I do this? RDD equals to SC dot parallelize. So parallelize is what? Parallelize is used to convert list into RDD. If you can see this function we used here, we will be using in upcoming session. So what is the role of this parallelize? It's converting data into RDD.
Yeah.
Okay. So to check the contents of the RDD, I'm going to print this RDD dot dot collect. The same function we are using since first day. Can you see this RDD is there, and this is just printing everything. Now if I need to check the type of this RDD, which is consisting the same Siva, Sachin, Manish, Lavya, Varun, can you see this is not the list right now. This is RDD dot, and what is this RDD? RDD is the basic abstraction in Spark, represents an immutable partitions collection of elements that can be operated on in parallel. So when you need parallel processing, so parallel, what do you mean by parallel processing? So parallel processing means, for example, I had this data set. This is, let's say, this is the marks here, right? So this is marks what? 30. Sachin got 25. Manish has got 41. Lavya got 47. Varun got 72. But if I ask you to hey Siva, just add 20 in each marks. So how would you do? So how would you do? Of course you have single brain. So using that brain is kind of CPU, and you will add this. This is add 20 in marks. So you say, okay, Sachin, I'll do this one. This is the 50. All right. Next, you will give
Yeah.
45. So if I take 1 second to operate 1 second to operate one operation, so this will be 1 second, then second 1 second, then this would be 61, then this would be 67, then this would be 92. How many second I took here? What is the time taken here?
Uh, 0 seconds.
No, like if I take one
Okay.
second to operate this addition in for single marks, 20 marks for Siva, adding 20 marks in Siva marks. So if I take 1 second here, so in order to perform all the operations, how many seconds I had taken to perform this operation? So
Mm,
1 second for Siva, 1 second for Sachin. Is it clear?
yeah, Sachin.
So total how many second do I have
Uh,
to finish this task?
97.
No. No, 1 second for Siva. Siva, I need to add 20 in Siva marks. So I'm taking 1 second to add this 20 in this marks.
Yeah.
1 second for Sachin, 1 second for Manish, 1 second for Lavya, 1 second for Varun. The total time taken here,
Uh, 1 second.
no, I have done till now. Initially, I started this data source. Here in this data sets, you will find this 17 MB file folder. I'll upload this folder in my Google Drive before starting this session. I had this folder, this file in my big data PySpark. You name it anything like Sachin PySpark or Siva PySpark project or Capstone project or Azure project or any name you can name it, any folder for this one. Inside this folder, you just go here, new, try to file upload. In this file, you will get this 17.53 MB dot zip file. If you will unzip this file, you will get more size. This is the zip folder. So if I go back here, go for the download. If I show this is the zip file, and if I unzip it, so this will be more size. The size will be more bigger. Now, once I have this file, I need to mount my Google Drive, establish dialog with my Drive connection. So using this code, I'm just speaking with my drive and walk you through this drive. I'll mount my drive here once it is successfully granted all the access. Now I'm going to initialize my Spark content uses this code and going to start my app and Spark configuration. Once it is done, I can read my text file and this is the address of my text file. How many partitions currently I have? So this is the partition. Currently I have this one. So by default, number of partition is determined by number of cores available in my machine. Let's say I am using a supercomputer where I have more than one core. So certainly this will showing more than one value. 2, 3, 4, 8 might be. If you are running in locally in your local computer, local laptop, so therefore it's showing 1. I just run this code rdd.glom. This one. So this is the this code will fetch all the rows in my text file. So here the number of rows 4,898,431, which is really big data set. So I just make it apart, make it in a single scenario. I just created a custom list which is having only 4 rows. 1, 2, 3, 4. Only 5 rows. Not this million rows. Forget about this million data set. I just created a data which is having only 5 rows. Using this 5 rows, I just convert into RDD, which is the parallel format. In this RDD, I just created the value which is showing here. Alright. Now in this RDD, let's see how many rows do I have. So if I'm going to show this the same code for my RDD currently, so I'm going to create this value. Can you see it's showing 2,3. Why 2,3?
Two partition.
This 2 is what? This is the number of partitions, and this is the elements in each list. All right. So in the same list, we had this number here. So if I show the scenario, so for example, RDD is divided into two partitions. Let's say this is the scenario. So you can visualize that RDD is divided into two partitions. Partition 1, this is the scenario. In partition 2, this is the scenario. So this is taking two partition. First one is two partition, and max how many rows do we have? So this will retrieve these count as a list. So 1, 2, 3, maximum 3 counts are there in my data set. This is the value where I am going to conclude it. Okay. So using this existing file, I need to create RDD for the specific reason. So say to create RDD with the specific reason number of partitions. So I'm going to use this code RDD equals to sc dot parallelize. So this is going to parallelize and going to data comma 4. So I need to partition into 4 parts. Right now,
Yeah.
I just finished this code, and now I just going to check number of partitions again. So using the different variable, I'm going to check partitions using this RDD. Going to get this data set. So get number of partition. This is the file. Can you see? If I try to print number of partitions, so here I'm going to print this file. Can you see? It's showing 4. Why? Because this divided my entire data set into 4 parts.
Into 4.
So this is the initially, if I show, this was showing only 2 partition, but now I'm having 4 partition. Now if I look at the same rdd.glom.collect, so can you see this is showing 1, 2, 3, 4. So in the first partition, I had the 2 data set. So let's say in the first partition, I had this one, Control X, Control V, Control X, Control V. So in the partition number 1, we had 2. So this is showing 2 data set. In the partition number 2, we had 3. So this is showing 3 data set. In the same scenario, now I had divided. So what is the scenario here? In the previous code, we had 2 data set, two parts. So this was the first partition. Here I had 2 things. This one, partition 1. In the partition 1, I had this one, Lavya, then had the Varun. So in the next partition, I had the Siva, then I had Sachin, and then I had Manish. So these 3 were accommodated in the next partition. So this was showing 2, 3. Then I run this code where we had the get number partition and deliberately convert into parallelize into 4 partitions. So now scenario has been changed. Over this scenario, I had 1, 2, 3, 4. So 1, 2, then 3, and then 4. So in the first scenario, if I look back here, what kind of 1, 1, 1, 2. So in the first block, I will have this maybe this 𝐒𝐿𝐽. In the second block, I will have this Varun candidate. In third block, I'll contain Siva. The fourth block, this will contain Sachin and Manish. So we cannot define this distribution, but by default they are distributing randomly. 𝐿𝐽, Varun, Siva, Manish, 1, 1, 2. Okay, you need four partition, so it will divide your data set in the partition. Now, in the previous session, you just told me to add the marks. This will take this one. Now, if I ask, there are so previously you were the only candidate to calculate this value, na? If I ask how many time will take to calculate this term, did you remember that one? So you said this will take 5
5
seconds,
seconds.
right? So why 5 seconds? Because you were only one candidate, one CPU or one brain was there, right? Now, how many brains do we had? We had 4 brains or 4 CPUs. Are you getting my point? Or four
Yes, Sachin.
employees to do the same things, which means I'm doing the same thing parallelize in a parallel scenario. So in a parallel scenario, how much time will it take? Let's say I'm doing the same thing, adding 20 in each marks. So I need to increase one 𝐿𝐽 marks by 20, Varun marks 20, Siva marks 20, marks Siva 20. So let's say here I have this candidate who is having employee 1. Let's erase this part because this was this one. So now currently I have employee 1 to do this task. Now I have the employee 2 to do this task. Now I have the employee worker 3 to do this task. Now I have this employee 4 to do this task. Now my question is how much time it will take to do this, to complete this process.
4 seconds.
Yes, exactly. Very good. Not 4 seconds. Oh, sorry. Not 4
5.
seconds. No. Total time. Let's say all they started this work. Start time is 10 a.m. Now they will finish. The employee 1 will finish this task at. It will take 1 second. So he will finish that 1 second a.m. Employee 1.
Yes, Sachin.
At what time employee 2 will finish this task?
10 to.
No, they are doing concurrently.
Okay. Okay. Got it.
Right? The same. And what is the time taken by employee 3?
10.
1 again. So because they are doing individually, independently, parallelly, concurrently, so they will finish at the same times. So optimally, this employee 4 will take time 2 because he is having 2 candidates to this thing. So max total time is what? Maximum total time to finish this task is now
2 seconds.
Yes, absolutely correct. The total time to finish this is now 2 seconds. This is the beauty of parallelism. Previously, we were finishing this time 5 seconds in 5 CPU. Why? Because we are doing the same thing here. 𝐿𝐽, then second, then third, then fourth, then fifth. This was the reason this task was finished in 5 seconds. Now, you already created this partition in your RDD, means you have hired 5 employees or 4 employees to do the same work. Now you can finish this task in 2 seconds only. So you made yourself familiar with the partitions now. Is it connecting now?
Yeah.
All right. So this is the VT of 11112. Now let's say I'm doing partition over the 5 here. I'm recreating this RDD for a specific number of partition. I'm changing this 5 here and checking the number of partitions again. Let's say how many partition do I have? Can you see? Now it's showing 5. If I run this command, which is checking the length, can you see? This is the 11111. Why? Now I am having how many employees? Employee 1,
Uh, employee 2,
yes. Employee
3.
3, employee 4, and employee 5. So
Yeah.
total time taken will be
5 seconds.
huh?
1 second.
Yes, absolutely correct. This is the beauty of parallelize, where we are doing the same work in fraction of seconds. Did I make you clear why we are partitioning? This is the very like most asked question in the interview. Why are you using uh, Spark? We are not using SQL? And this is the reason we jump to the Spark and we just left behind the SQL, because that partition and concurrent or that parallelized concept is not there in the SQL. This is only available in PySpark, and this is the reason it makes PySpark very important and very valuable. And most of the IT companies are looking for this one, this this PySpark code.
Okay, Sachin.
So let's print this value. So here I am going to use SC default. Let's say what is the default parallelize in my queue? So only 2. So I have 2 partitions. So let's print this value rdd dot get number of partitions. Here I'm going to get number of partition. I have 5, which I divide here. So if I use this value, so for example persist, I'm going to use this persist function. So can you printing parallelize collection rdd at a Python RDD Scala is 289. So this is the total function here. So if I go back here and just defining value, can you this is the official documentation where I have. So this is going to set the RDD storage level to persist value across partition after the first time it is computed. This can only be RDD does not have storage levels set yet.
Yes, Sachin.
I'm going to copy this line. Set the RDD storage level to persist after first time it is computed. Only to use to assign a new storage level if RDD does not have a storage level. Alright. Now, when we had custom dataset, now I'm going to read this dataset again from my file. I'm going to get partition here. I'm going to see how many partition do I have in my RDD. How many rows do I have? So it's saying this is 4,089,000. So I'm going to create this more part here. I'm going to convert the list into the RDD, and then let's check this RDD here. Now I'm going to have RDD in this content. This is the print.rdd. This is going to print my code because this is so many files are there taking much time. So file and oh, see, much big data set, so it's not going. Let's check this type of RDD. Yes. So maybe because of size or the very big data set, it's file. So I'm going to part. Now going to write RDD equals to RDD dot repartition. So this is going to partition, let's say 5 here. I'll have to run this.
Yeah.
Okay. This is just because I just connection refused because I had two configuration in a same folder, in a same repository. It cannot create the same repository. So I'll have to create this file here. Spark session. You focus here, I didn't change any code just because of just because of two Spark sessions, two configuration, it just throwing any error. Now once I had this partition, I will have to show the entire scenario. So what is this one? This is the glom code where I need to represent all the partitions. So let's see. This repartitions. What is this repartition? Can you see? This is the partition 1, partition 2, partition 3, and task 1, task 2, task 3. So this is the repartition. Let's say you want to divide your, so is it the good practice to perform all the 4 millions data set here? Of course not. I'm going to repartition into 5 blocks. Can you see these 5 blocks here?
Yes, Sachin.
So this is 4 million blocks are partitioned into 5 blocks. Now in the one worker, I'm having this one work. For the second worker, I had these rows. I assigned this one. For the third worker, I assigned this much star, and the fourth worker, I assigned this much star, and for fifth worker, I assigned the many rows. So now it's easier to perform this task because they are all doing concurrently. And now you are familiar with the concurrent term and the parallelize inside the term. So why I'm doing this practice using the partition? I'm dividing this 4,089,000, which is very large. I'm dividing into 5 partitions using this repartitions dot 5. So this number is what? Number is number of partition inside the processing. 5 here. It can create increase or decrease level of parallelize in the RDD. Internally, this uses shuffle to redistribute data. If you decrease the number of partition in the RDD, consider using collapse, which can you avoid performing a shuffle. So I'm going to this one part repartition. If I repartition in 10 portions, you said that this is still very large. These blocks are still very large. So I can partition into 10 different quotations. Can you see? Now this is 10 partition. Now my 4,080,000 is divided into 10 different equal partitions. Is it connecting?
Yes, Sachin.
If I want to see the default partitions here, can you see default partition, and this is 10 partition. All right. Now,
Yes.
if I show this one, this is the data frame, which is divided into 128 MB, 128 MB, and this is third partition. And this is the task one, this is task two, and I'm going to perform this green, yellow, and orange in parallelly. So this 300 data frame is divided into 128 MB, 128 MB, and 46 MB. So this is partition into different tasks, a small piece of chunks. So you can take a pause for a moment to discuss any question, any query you have.
So usually it will take time to run, right?
Of course, find out 10 simple. For example, you have 1 TB data. So 1 TB data processing 1 TB file is ideally very fast. Very tedious task for any computer. Maybe your system got hang. What exactly you will do? You will partition your data set 1 TB file into 100 partitions. Now this 100 partition will find out all records into small chunks, and then it will perform that action which you want to do there.
Yes, Sachin.
All right. So this
Yeah.
is the this is the transformation, and I'm because this is not the single transformation. I need to perform so many transformations here. So I'm going to use this parallelize concept over here. PySQL, I need star streaming, machine learning, graphics. So I need to, so let's say I'm going to start partitioning. Partition. This is the partition. So departition. PySpark side breaks RDD transformation map quiz filter distinct by count by less. Yes. Can you see the partition? Repartition is used to change the number of partition in RDD. Will create new RDD. So I'll use RDD dot repartition number of partition. Is it connecting?
Yes, Sachin.
Okay. So any doubt on this till here?
No, Sachin.
Okay. So